Welcome to a new video presented to you by APC Mastery Path. APC Mastery Path provides videos related to how to implement the latest artificial intelligence and machine learning within our beloved construction industry. This video belongs to a series of videos that will tackle how to use open-source LLMs to build a tool to convert PDFs to a functioning and useful podcast. The system that will be presented in this series relies on four main pillars. Pillar 1, PDFs loading and preprocessing. Pillar 2, writing transcript. Pillar 3, refining the created transcript. Pillar 4, text-to-speech workflow. We will discuss the whereabouts of Pillar 1 related to the loading and processing of PDFs in two videos. The first video will showcase how to set up the coding environment, load the PDFs, extract raw text and save that raw text in a file. The second video will continue to showcase how to use open-source LLMs to make sense of the extracted raw text and reword it to make more sense in preparation for the next steps. Having understood how we are going to tackle this project, let's dive in. This project was crafted by the Meta team and they have provided the full code on one of their GitHub repositories that I will be putting the link for in the video description below. I have also created my own refined code and uploaded it to a separate GitHub repository, which I am going to be providing the link for in the video description below as well. This will make the process of following through and implementing the project much easier for the listeners. As discussed before, we will be showcasing in this video how to set up the coding environment, load the PDFs, extract raw text and save that raw text in a file. Before we dive in, we will need to have Python version 3.10 plus installed alongside an integrated development environment such as VS Code. We will also need to create a virtual environment, which will be our safe haven to install all the dependencies and required packages. On my GitHub repository, there is a file named requirements.txt. This file contains all the dependencies required for this project to work smoothly. You can start by creating a virtual environment by opening a terminal window in the folder where you are going to save your project. You can then type in the following lines of code in your terminal. Python mvenv notebook_llm. Notebook_llm /scripts/activate. Pip install our requirements.txt. This could take some time because PyTorch would need to be installed, which has a size of circa 3 GB, so keep that in mind. Once the environment is set up and all the dependencies are installed, we can then start the steps of our code. Step 1, importing necessary packages. We will begin with importing some necessary packages such as tkinter for creating dialog boxes for the end user to choose the PDF of choice. We are also going to import pypdf for processing PDFs and extracting raw text from them. Step 2, initialize PDF paths list and define file selection function. In this step, we are initializing a list to store PDF paths and create a function that lets users select files. The end goal of this step is to allow users to select PDF files and view basic information about each file immediately. We managed to do this goal by creating an empty array named PDF_paths, which is then going to store the paths of the selected files. We also made sure that the available extension to select is .pdf. The end result is an array which contains all the metadata for all the selected files. Step 3, validate PDF function. In this step, we are checking if a selected file is a valid, readable PDF to prevent errors during extraction. This step aims at ensuring the program processes only valid PDF files. We deployed the pypdf packages to begin skimming through the PDFs and extract data from them. If the pypdf finds an error with the selected file or files, then it sends the end user an error message. Step 4, PDF metadata extraction function. In this step, we extract metadata from each PDF, helping users understand file details. This step aims at providing helpful file context before text extraction, such as page count and document properties. The code in this step makes use of the validate PDF function developed above to extract the metadata only of the valid PDFs. Step 5, text extraction from PDF with character limit. In this step, we extract text from each page of a PDF with an optional character limit to manage text size. This step aims at controlling text extraction, providing manageable output for large PDFs. The code in this step checks if the file is valid by calling validate_pdf. It reads the PDF page by page, extracting text. It accumulates text up to a specified character limit, max_chars, default 100,000 characters. It then checks if adding a page's text would exceed the limit, stops, and adds only the remaining allowed characters. The code then returns the extracted text up to the limit as a single string. Finally, the code handles errors, such as invalid or corrupted PDF files. Step 6. Text extraction, preview, and save function. In this step, we combine the steps of metadata display, text extraction, preview, and file saving. The aim of this step is to create a complete extraction workflow that previews and allows saving of text output at a user-specified location. The code in this step iterates through each PDF file in PDF_paths. It then extracts and displays metadata for each file. The code calls extract_text_from_PDF for text extraction. The code displays the first 500 characters of each PDF's extracted text as a preview. It appends each file's text to combined_text, ensuring the total doesn't exceed 100,000 characters. The code then opens a save dialog where users can select a location and name for the output file. The code gives the end user the capability to save combined_text to the chosen location. Step 7. Tkinter graphical user interface setup. In this step, we create a graphical interface for file selection and text extraction. The aim of this step is to provide an accessible graphical user interface with buttons for PDF selection and text extraction saving. The code in this step sets up a Tkinter window titled PDF Text Extractor. The code then defines a button for selecting PDF files and another for extracting and saving text. It runs root.main loop to keep the GUI active until the user exits. The main output after implementing the steps above is having a text file that contains the extracted text from the desired PDF or PDFs. The raw extracted text contains lots of irrelevant data such as page numbers, lots of unnecessary spaces and symbols. This uncleansed extracted text will then be processed further to have a more meaningful backbone for the podcast that we are going to create in the next videos. All the files that we are explaining in this series of video are available on my GitHub repository provided in the video description below.
Thanks a lot for watching. Hope you found this video useful and insightful. I've prepared a couple of other videos about fine-tuning large language models and deploying them to OpenWeb UI. I'm going to be putting the links in the description below. You can also pay my website a visit at www.apcmasterypath.co.uk, where I provide multiple packages for the RSS APC candidates to support them throughout their RSCS journey. Also, I provide lots of insights about the RSS APC process, the different areas of competence, and how you can deploy AI within the construction industry. Do not forget to hit the like button and subscribe so that you get notified about our latest videos.